Meanings of division and interpreting division situation. We're going to explore ways to think about division and also situations that have division. Since this is a mashup, there are kind of a lot of I cans here. I can explain two ways of interpreting a division expression, such as 24 divided by 3. When given a division equation, I can write a multiplication equation that represents the same situation. I can create a diagram or write an equation that represents division and multiplication questions. And I can decide whether a division question is asking how many groups or how many in each group. So once you've got all that information down, today's date, you also want to go back and put in your table of contents, this is a new unit, Unit 4, talking about division with fractions. And once you got that, you're ready to go on. All right, so let's look at some expressions with division. So we have 20 divided by 4. What else can we think of with this? Well, we can think of how it is 20 is divided by 4, okay? We can think of it as we're trying to see how many groups of 4 we can take out of 20. Or we can also talk about how many groups of 4 we can make out of 20. So I know that says the same thing, but it's a little bit different wording as far as what you're talking about. We can also think of it as not only 20 divided by 4, but we can also think of it as 20 times something. Yeah, you could think of it as how many, think of it as not how many, but 20 groups of 1/4. How many would you make there? So you can think of dividing by a whole number as multiplying by the reciprocal. And reciprocal is just thinking of the fraction here and flipping it. We'll talk more about that as we get in. All right, let's talk about a bag of almonds. Baker has 12 pounds of almonds. She puts them in bags so that each bag has the same weight. In terms of pounds and bags of almonds, what would 12 divided by 6 mean? A few different ways that you can think of that, right? So you're thinking about 12, that's 12 pounds of almonds divided by 6. Well, what could that 6 mean? Could mean that you're dividing it up into 6 bags, right? What about dividing into bags with 6 pounds in each of them? Yeah, I mean, either way, at the end of the time that you're doing it, you're still going to get a 2. But what does that 2 mean? If I say that we have 6 bags, then at the end you're talking about that each of the bags has 2 pounds in it. If I say that it's 12 pounds broken up into 6-pound bags, that means that you only get 2 bags. So it's still 2, but it's that labeling that makes the difference. What about here? We got Claire and Tyler drew diagrams and wrote the equations for each to show their thinking. Claire is thinking of it as something times 6 is equal to 12, whereas Tyler is thinking of it as 6 times something gave him 12. So you can see that they're thinking of it, and they're coming up with the same numbers in both situations, right? But the numbers are representing something different in each situation. It's just like we just talked about a second ago, that when you're talking about in the one, if you're thinking of it as 12 divided by 6 equals 2, and you're talking about into 6-pound bags, that's kind of what we're talking about here. If you're talking about that there are 6 bags, then this is talking about 2 pounds in each bag. So it just really just depends on what you're thinking about as far as how you're explaining it. and what the question's asking for too, you know. Okay, so now we've got some division still with that original 12 pounds. What do each of these mean? Well, here we've got 12 divided by 4, right? So you can think of it as two ways. One, you've got it broken up into 4 bags. How much is in each bag? 3 pounds per bag, right? You could also think about, dividing it, that you've got 12 divided up into 4-pound bags, which is going to give you still 3, right? But again, it just depends on which way you're looking at it. Either way, the answer that you get here is still 12, or is still 3, but it just depends on what you're looking for. Here, same thing, right? This is kind of a flip of what we just talked about on the previous part. How you've got either it's 12 broken up into 2 bags, giving you 6 pounds in each bag, or 12 broken up into bags of 2 pounds. How many bags do you get? So it's still 6. What about here? What's 12 divided by 1/2? Well, this 12 is, or this 1/2 is trying to see how many 1/2s you can get out of 12. There's 1 and another 1, so that makes 1 whole. There's 2 whole, 3 whole, 4 whole, 5 whole, 6 whole, 7 whole, 8 whole. I'm going to have to add a few more here. 9 whole, 10, 11, and 12. So each one of these represents 1/2, right? But we have 24 of them altogether, don't we? Because we're trying to see how many 1/2 groups we can take out of 12. So in this situation, you're talking about 12 divided up into 1/2 pound bags, you get 24 bags. Or if you've got 12 and you're dividing it up into half bags, how many half bags can you fill? 24. So it really just depends on how you're reading the problem again. It just depends on the situation. So how could we group 20 or interpret 20 divided by 8? We can think of it as how many groups of 8 are in 20. Or we could be thinking about how many if we make 8 groups, how much is in each group? Or how much is in each group if we break it up by 8? What's the multiplication look like for 8 divided by 20? What's the multiplication version of it? Yeah, it should be 20 times 1/8, right? It's going to give you the same thing. It's just looking at it in a different manner. Let's talk about some jam. So Mai had 4 jars. In each jar, she put 2 1/4 cups of homemade blueberry jam. Altogether, how many cups of jam are there in the jars? Here, this one's pretty straightforward, right? You have 4 jars. Each jar is 2 1/4. This is going to be, you're going to multiply 4 times 2 1/4, right? We'll look at the diagrams in a minute. What about this one? Priya filled 5 jars using a total of 7 1/2 cups of strawberry jam. How many cups of jam are in each jar? Is this still 5 times 7 1/2? No, it's not, is it? We have our total of 7 1/2 cups, and now we have to break that up into 5 jars. We could also think of it as taking and doing the 7 1/2 times what? Yeah, 1/5, right? Because multiplying by 1/5 would be the same as dividing by 5. What about here? Han had some jars. He put 3/4 cup of grape jam in each jar using a total of 6 3/4 cups. How many jars did he fill? So now we have a total of 6 3/4. And we're going to break that up into 3/4 cups jars and find out how many we make in there. Let's look at what that would look like as a diagram. So here, it's just like we talked about a second ago. You've got 4 groups of 2 1/4, and that gives you your total. Here they talked about this a little differently. I said it was 7 1/2 divided by 5. Well, isn't that also thinking of 5 jars, something in it? Think of it as a missing number here. 5 times something would give us the 7 1/2. So this still could be thought of as 7 1/2 divided by 5. What about here? This something times 3/4 gives us 6 3/4. Does that still work? Yeah, because we know in one jar we have 3/4. We don't know how many jars here are in between, but we know that however many jars here times 3/4 gets us 6 3/4. So it's just another way to look at it. And still even showing the same thing, but that we're looking at it solving in a different manner. All right, let's talk about some granola. So to make one batch of granola, Kieran needs 26 ounces of oats. The only measuring tool he has is a 4-ounce scoop. How many scoops will it take to measure 26 ounces of oats? Is that going to be more than 1 or less than 1 scoop? What's this going to look like as a multiplication and a division? Well, you can think of it this way. We can think of it as we don't know how many scoops it's going to take times the 4 ounces in each is going to get us 26, right? How can we think of it as a division? Yeah, it's just 26 divided by 4 is going to give us the number of scoops. And we can see that in just a second. Recipe calls for 14 ounces of mixed nuts. To get that amount, Kieran uses 4 bags of mixed nuts. So what can we figure out here? Same sort of thing again, right? We know that we need a total of 14 ounces of nuts. We know that we're going to use 4 bags. And actually, I've got this backwards. We got 4 bags times however much is in each bag is going to give us 14, right? What's this representing? What's this question mark representing? So here you're talking about if it's 14 divided by 4, because you're dividing up those 4 bags to find out how many ounces are in each. So this tells you how many ounces are in each bag. So if we use what we were talking about earlier for the first part with the oats, we take that 26 ounces of oats, break it up into 4-ounce scoops. We end up with, 6 1/2 of a scoop. Why is this 1/2 of a scoop? Well, we said that one scoop was 4 ounces. So 6 times 4 is 24. So you get 24 ounces. You still have 2 ounces left. Well, they still use those 2 ounces. So that's why it's 6 1/2 scoops. What about here? We've got 14 ounces. We've got 4 bags. How much is in each bag? Well, we know that 4 will go into 14 3 times, right? So each one of these is worth at least 3 whole. And how much is left? Yeah, we've got still 2 left over, right? And it was divided by 4. So we have 2/4 left over that goes for each bag, right? Does that work out math-wise? Or if we have 3 1/2 for each of these, does that still end up making our 14? Yeah, 4 times 3 is 12. 4 times 1/2 is 2. That still makes our 14. So each one of those bags is 3 1/2 ounces. So what's the unknown part in each one of these? Flour is sold in 3-pound bags. How many pounds are in 7 bags? Yeah, we're trying to figure out the total pounds, right? What about here? 5 tickets to play cost $38. What does each ticket cost if they all cost the same? Here, you're talking 3 bags times 7 gives us some answer, right? Here we have 5 tickets to a play, cost $38. What's this look like? Well, we got our 5 tickets times some price gives us the $38. One quart is equal to 32 ounces. How many quarts are in 128 ounces? Here, we know that for each quart, there are 32 ounces and equals 128. And just like we did with the previous diagrams, we can break it up in whatever way works best. All right, this is a little long. Sorry about that, but there's a lot to cover in this particular one. Thanks.